Hello, girls and boys. It is Mr. Chameleon Colin here. Today we are going to be learning about estimating multiplication products. And I don't know if any of y'all know why I became a teacher, but I really became a teacher because I think all of my students are really, there's a lot of students out there, but my students and fourth grade students here at CWC are all really one in a melon. One in the melon. Get ready for a punny lesson today. I hope you like fruit jokes. Today you need a student reference book. You need your math journal. You need pencil and paper or whiteboard and marker, just like normal. And while you're getting your materials, I've got another joke for you. What happened to the pig who liked pineapple? What happened to the pig who liked pineapple? She turned into a porcupine. But ting. So you should all have your materials. These are all the things that we need for math every day. So this is nothing new. We should have our materials and ready to go. So today's math message is a little bit different. We're all answering the same 3 questions. So you need to write down on a piece of paper, because you're going to need these again. So don't use your whiteboard. Use your piece of paper. How many eggs did you eat in the last 7 days? Number 2, write the answer to this on your paper. How many cups of milk did you drink in the last 7 days? And the last question, number 3, how many slices of pizza did you eat in the last 7 days? So you should have 3 numbers written down: the number of eggs, the number of cups of milk you've drank, and the number of slices of pizza you've eaten in the last week, in the last 7 days. Okay. And real quick, I need somebody to come off mute once you're called on and remind us how many weeks are in a year. How many weeks are in a year? And then once you have your answer, if you round that number to the closest tens, what do you get? So this is going to be important for the next part of the lesson. So how many weeks are in a year? And if you round that to the nearest tens, what answer do you get? Okay, so everyone's answered these 3 questions. You now all know there's 52 weeks in a year. And if you round that to the nearest tens, you get 50. And now you've got 3 more questions to answer. So using your answers for the first 3 problems, think about how could you answer these next 3. So the first one, I will eat about how many eggs in 1 year? So if you know how many eggs you eat in 1 week, how many eggs might you eat in 1 year? If you know how many cups of milk you drink in 1 week, estimate. So we're using our estimation skills. You can use a little bit of multiplication. And how many cups of milk will you drink in 1 year? And then the last question, I will eat about how many slices of pizza in 1 year? So you use your answers for number 1, number 2, and number 3 to help you estimate your answers for number 4, number 5, and number 6. So teachers, you can pause here and give your students a minute or 2 to think about their answers and then really estimate using your multiplication and your estimation strategies, the answers for 4, 5, and 6. Okay, so we have our answers for these 6 questions written down on a piece of paper. And now we need our student reference book out. So get your student reference book out and flip to page 286. Go ahead and pause here to give students a second to do that, but be quick because we already have our journals, or we already have our books right next to us. Okay, so we are all on page 286, and I need a volunteer to read the first part of this page. So the first paragraph, start with what do Americans eat and stop with food per day. So one volunteer who's ready to read this paragraph for the whole class. And we'll pause here, teachers. Okay, And then the last part of this, if you didn't already read it, is below on the second half of the page. The most current results show that Americans eat or drink about the following average amounts of these foods in 1 year. So we've got different amounts of food and different types of quantities. So let's look at that. Let's really try and think outside the pizza box here, and let's compare our answers to the answers that the average American gives. So this page would tell us that the average American eats about 249 eggs a year. Is that close to what you wrote? More than? Less than? The next one that we have a star next to. The average American, so the average American, or how much? Yeah, drinks 362 cups of milk in 1 year. And the average American eats 46 slices of pizza in 1 year. Now, I want us to look at the top of this page, and I want us to think, we've got this sentence. It's the second to last sentence of our first paragraph. So it says, Americans eat on average more than 2,000 pounds of food per year. What is meant by this? So does this mean everyone eats 2,000 pounds of food a year? Does this mean everyone eats 2,000 pounds of food a year? Teachers give a couple students the opportunity to answer that question, yes or no. Does every person eat 2,000 pounds of food per year? Okay, so we have our answers. Now, does every person eat 5.5 pounds of food every day? Would you guess that you eat and drink more or less than 5.5 pounds of food per day? Okay, so now that we've done that, we can think to ourselves, so just because the average person eats 5.5 pounds of food per day, that doesn't mean every person eats 5.5 pounds of food per day. When we look at these numbers below, do any of these numbers surprise you? So teachers, you can ask that question. Students, you have a chance to respond. Do any of these numbers surprise you? Did you think people would eat more apples or less? Did you think they'd eat more broccoli or less? Okay, so we can answer that question. And then the next question, do you think any of these numbers have changed since this was last collected? So do you think that people are eating, let's say this was collected 5 years ago. So 5 years ago, people were eating 21 pounds of candy every year per person. So the average American was eating 21 pounds of candy a year. Do you think people are eating more candy now, or less candy now, or the same amount of candy now? So right now we're just talking about these numbers. Are we surprised by them? Do we think any of them should be more or less? We're really trying to think outside the pizza box. Okay. Now we got a couple more questions that we want to think about. We want to think about, again, do our numbers match these other numbers? So do we eat the same number of eggs per year? Do you also eat about 250 pounds of, or 250 eggs a year? Thumbs up if you eat about that much. Thumbs down if you eat way less. And 2 thumbs down if you eat more. So if you eat more than 250 eggs a year, 2 thumbs up. If you eat less than 250, 1 thumb down. And if you eat about 250 eggs a year, 1 thumb up will do. So I just want to think, how do our numbers that we guessed with our math message, so how do these numbers that we guessed when we answered 4, 5, and 6, how do those 3 numbers compare to our starred numbers right here? They more or less, we can have a little class discussion about who we think eats the most pizza, or who we think eats the most fish, or who eats the least amount of eggs. We could have a quick class discussion about that. So after we're done with our class discussion, we want to talk about why don't we use estimation for everything? Why don't we use estimation for everything? Now, before you answer that, I have another question for you. Why did the banana go to the doctor? Because it wasn't peeling well. Okay, so now I want to know, I want you to tell your teachers, why do you think we don't estimate everything? How come we don't always use estimations? Go ahead and pause here and give some time for a class discussion. Next discussion question. Is everything capable of being estimated? So don't just think of numbers, think of whatever you can think of. Can you estimate anything? It's kind of a big question, so you might want to think about it for a second. But when you're ready, you can tell your teacher what can you not estimate, or what can you estimate? So is everything capable of being estimated, yes or no, and then why? Okay, last discussion question. Sorry, teachers, you pause there, have that discussion. Last discussion question. Why not just solve the problem to get an exact answer? Why do we want to estimate at all? What's the point of estimating? I mean, like, why not just go ahead and solve the problem so that we know what the answer is, and then we don't need to estimate anymore? Why don't we do that? Go ahead and have a class discussion. Why would we not do something like that? Okay, I want to review now that we've talked about estimation. We've talked about the amount of food that different Americans eat, or that the average American eats per year. And we've talked about how much food you probably eat per year. Now I want you to do some estimation. I want to review some estimation strategies. Ms. Parks actually taught us about this maybe a month ago. She taught us estimation strategies. So let's review them real quick. Front end estimation. So this keeps the leftmost or the highest digit in our number and puts 0 in for all other digits. So if we have 56,412, we just look at the leftmost highest digit, which is in our 10,000s place. That's a 5. And it's front end estimation, so we just keep that 5 and put a 0 for everything else. So instead of this complicated number, we just have 50,000 now. We've got 4 zeros and a 5, that's it. Now let's look at another estimation strategy. Close but easier numbers. Choosing numbers that are close. This is choosing numbers that are close but are easier for you to use. So let's say we're trying to add together 56 plus 54. Well, 50 is close to both of these numbers, and it's a little bit easier to work with. So we change 46 to 50, and we change 54 to 50. So we change 46 to 50 and 54 to 50, and then that would be a close but easier estimation. And then the last one, rounding to the place value. So round your numbers. This is rounding to the place value of your choice or your teacher's choice. This is the most common estimation we use in class whenever we're doing mental math. So maybe Miss Parks or Miss Wolf or I will say, okay, round to the thousands, round to the hundreds, round to the nearest 10,000. That's rounding your numbers. So that's a different kind of estimation strategy than front end estimation or close but easier numbers. So if we were to take the same number, 56,000, and use a different estimation strategy, so instead of our red front end estimation, we would use our orange round your numbers. And now we would round our 10,000s place using our 6 because it's in our 1,000s place, and we always round with a digit directly to the right, one place value lower. So we go 10,000, one place value lower is 1,000s. 6 is bigger than 5, so we round up to 60,000. We put a 0 in for all the other numbers, and now we've tried 3 different estimation strategies. So that's just a little review. We learned that a while ago with Miss Parks. So now we're going to practice this together a little bit. So we know that these are the numbers for however many pounds or eggs or whatever cups the average American eats or drinks a year. So if we say about how many pounds of bananas, so if the average American eats 25 pounds of bananas a year, that's making me go bananas, then, then about how many pounds of bananas might the students in our class eat in 1 year? Okay, so we need two numbers. We need to know how many pounds of bananas does the average American eat? Well, that's 25. So here's our first number, 25. And then how many students are in our class? In my class, it's also 25, but in Miss Parks or Miss Wolf's class, it might be 24 or 25. But let's again use some estimation strategies and let's use some easier numbers. So what is a number that we could use that's close to 25, 30? We could just round our tens place. And I'm using the rounding strategy. But this could also be close but easier numbers. So we've got 30, because I like to have 0 in my ones place. And then if we've got 24 students in our class, or 25 students in our class, we'll just say we've got 24 students in our class, because then we can round down. We can round down and we can say, okay, 24 rounded down. Well, we take our 4, we round our 2, so that becomes 20. So we'll say we have about 20 students in our class. We have about 20 students in our class. And we've got about, every student eats about 30 pounds of bananas. Let's use yellow instead of blue. Let's use yellow. Okay. So every student eats about 30 pounds of bananas. And there's about 20 students in the class. Sorry. So we would do 30 times 20. And then we can use this cool, we'll do this again, make this a little thicker. Do 30, that's better, 30 times 20. And we can use our same strategy that Miss Parks taught us yesterday, actually. And what we can do is we can look at our original fact, the easiest fact here. The easiest math fact here is 3 times 2. So yesterday, that's the kind of multiplication extension we were practicing. So 3 times 2 is 6. Let's put that answer in black. 6. And then we have to have the same number of zeros in our problem that we do in our product. So our question and our solution need to have the same number of zeros. So there's 1, 2 zeros. So I'll put 1, 2 zeros. So what this would mean, what this answer means, is that we've got 30 pounds of bananas. Every student is eating 30 pounds of bananas. There's about 20 students. So about how many pounds of bananas might the students in our class eat in 1 year? 600 pounds. I mean, 600, that is, I mean, come on, you got it, but that's bananas. 600 pounds for just the students in our class? I mean, that is a lot of bananas. So that's how we would answer this one. Let's try one more. Let's try one more together. This time, let's talk about those eggs. Oof, I love eggs and bacon. Okay, so the question this time is about how many eggs might an average family of 4 eat in 1 year? So if the average person eats 250 eggs, 249, but I'm going to go ahead and use 250. I keep saying that. It's so close. It's a close but easier number. So I'm just going to use 250. So it's a family of 4, though. So the average one person eats 250 eggs, but we've got 4 people eating eggs in the house. So if each person eats 250 eggs, then we would do 250 times 4. We do 250 times 4. Oh, I'm getting hungry. Eggs and bacon sounds good. We got 250 eggs times 4 people, because there's 4 people in the family. And let's ignore this 0 for a second, and let's just focus on 25 times 4. Well, a quarter is worth 25 cents, and it takes 4 quarters to make $1, to make $1. So $1 is worth 100. So if we just ignore this 0 and we did 25 quarters, we had 4 quarters, each worth 25 cents, then that would give us 25, 50, 75, 100. So if we just did, our original fact was, I'll just erase this 0. If our original fact was 25 times 4, then that would equal 100. But that's not what our problem wants to know. Our problem wants to know if I've got 250 eggs and I've got 4 people in one house eating all those eggs. Oh my gosh, this is going to be a big number. Well, then I can take this down, but I need to add one more 0. I need to add one more 0. So in this case, the number of zeros that we have in our product doesn't match the number of zeros that we have in our question, in our factors. And that's okay, because this question's a little bit different. This one, our original fact has zeros in it, and the ones in the tens place, and the ones in the tens place, our original fact has zeros in it. But the other questions that we do typically don't have zeros in the ones in tens place. So that's why this problem has more zeros in the product than it does in the question. But this 1 0 over here, we add right there at the end. So teachers, feel free to pause here and go over this a little bit more with the students if you think anyone might be struggling. And we're going to do this last one as a class. So I'm not going to explain it. Miss Parks and Miss Wolf will work on this one with you. So you can pause here and read through it and work on this question together. Students, you can try it on your own, and we'll be back together in just a second. All right, so everybody answered this question together.